Hey, we're at go2math.com working some application problems involving linear equations. So we've got 2.2 here. It says find three consecutive even integers so that the first plus twice the second. Wait a minute. Whoa, we already did that problem, didn't we? Hold on. 1 second. One, two, 2.1. 2.2. So where I was at? 3. Okay. I don't know what's going on here. Okay. 2.2. Find three consecutive even integers so that the first plus twice the second is twice the third. I think I confused myself on that. Find three consecutive even integers so that the first plus twice. Okay, so this is what we're going to do this. We are going to let the first even integer, I think we'll just let, okay, this is how we'll do this. We'll let x of 1 be the first even integer, then x of 2, and x of 3. So these are our three consecutive even integers. Okay? Now we need to find a relationship between x of 1, x of 2, and x of 1 and x of 3 is what we're going to need to do. So we're going to let x of 1 just be the first even integer. Now the relationship between x of 2, here let's just write it over here. X of 2 is equal to x of 1 plus, now remember they're consecutive even integers. So actually here's an example, 4, 6, and 8. Right? So that's an example of three consecutive even integers. Okay? So basically if we add 2 to the first one we get 6. See that? By adding 2 to the first one we get 6, and if we added 4 to the third one, or the first one, add 4 to the first one, we would get the third one. Okay, so the second even integer we're going to be adding 2 to it, and then the third even integer we're going to be adding 4 to it. Okay, so hopefully that makes sense there. Okay, all right. Okay, so now we're going to go back up and read the sentence. So we found the three consecutive even integers so that the first plus, so this is the first even integer, plus twice the second, so twice the second even integer is twice the third. So remember, is means equals, is twice the third, and of course that shouldn't be 3 written there. Somebody should have told me about that. Right? This is the third even integer, so this would be x of 1 plus 4. Okay, so we've got our equation now written up, and what we'll want to do now is solve for x in this problem. Okay, or solve for x of 1, I should say. Alright, so let's do that. So we have x of 1 plus, go ahead and distribute this 2 across, 2 times x of 1 plus 4 is equal to 2 times x of 1 plus 8. Alright, now let's go and collect up our like terms here. We got 3 x of 1 plus 4 is equal to 2 x of 1 plus 8. Alright. Okay, so let's go ahead and take that 2x of 1 over to the left hand side. So we'll have 3x of 1 minus 2x of 1 is equal to 8, and then take that 4 over to the right hand side. So we end up with a 4 here, and it looks like that's just going to be x of 1, right? Now, I just now seen something. Anyway, so I'll tell you about it here in just a second. Okay, so our first integer is 4, and of course this is our second integer. We just add 2 to it. That's going to be 6, and then adding 4 to this one here, we get 8. Now what we'll want to do here is we can go back and actually check this, right? We can go back to, so here's our first integer. Well, I didn't mean to write that. Plus, now remember what it said here, twice the second integer is equal to twice the third integer. So let's actually look at this. So this is 12, right? And 12 plus 4 is 16, and of course 2 times 8 is 16. 16 is equal to 16. Bam. Okay. Now, I didn't actually mean to write the answer up here. I just, for some reason off the top of my head, let's just do 468 for an example, and it turned out that was the actual answer. So it's been a while since I actually came up with this problem, and I guess I just totally forgot about what the answer was. But anyway, alright, so we're over here at gotomath.com getting it worked out, and I'll see you in the next problem.